Everyone. This is Martin. I'm standing in Australia, presenting to Turkey. This is my first time presenting remotely, but you've been to the conference for the whole day, so you've probably seen a lot of sessions. I've seen the keynote yesterday. It's a strange new world we live in, but it kind of works. So my talk today is about future of Jira software powered by Kotlin. As I said, my name is Martin, and I work for a company called Atlasian. This company is probably known to you for its products, like Jira, Confluence, maybe Bitbucket, but it's also a little bit known for one more thing. If I open my browser and I go to the Kotlin Lang website and scroll a little bit down in the Kotlin usage highlights, there it is. Atlassian is also known for using Kotlin for a while. It says here that all new code in the Trello Android app is in Kotlin. You might know Trello. It's a collaboration tool to organize any kinds of projects, boards, lists, and cards. And this is how the Android Trello mobile app looks like. This is a true Kotlin pioneer because the first commit that had any Kotlin in it happened in October 2016. If there are any Android mobile devs here, you know that that is before the endorsement by Google. It was Kotlin version 1.0.4. But today is not just Trello. All our mobile apps for Android now use Kotlin. Jira for cloud and server, Confluence for cloud and server, and also ofjira. And it's not just mobile. More and more backend services at Atlassian are written in Kotlin. So let's focus on Jira software. After all, this talk is called Future of Jira Software Powered by Kotlin. And what is Jira software? The encyclopedia definition is that it's a tool that helps you plan, track, and release software. And if you have used Jira before, Jira is the issue tracking system, and Jira software are the agile tools on top of it, the boards, sprints, reports. But the more interesting part is, what is Jira software from developers' perspective? And for that, we'll have to make a little trip into the past. It all started in 2002, where Jira was released for the first time as an on-premises product. It was a Java application that you could run yourself in your own application server. And the first cloud version was exactly the same. It was the same code base, just deployed in our own data center. You can imagine that that was not very maintainable because the requirements for the cloud and server versions are very different. Also, we had to deploy this cloud version in a dedicated server for each customer. So in 2016, Atlassian decided to fork this code and create separate server and separate cloud versions. So at the beginning, the Jira Cloud was just a big monolith, which was the legacy of this shared code base. And Jira software was part of it. It was all written in Java with a little bit of Scala. And there were groups of developers working on the monolith together along other teams. So Jira software developers would work with other Jira developers. And as the code base grew, the number of developers increased. And the actual happiness of those developers decreased. And the bigger the monolith grew, the worse it was. And if we didn't stop right there, I think something like this would happen. So we wanted to prevent that and took a really good look at the code base. We identified code that belongs to Jira software, but doesn't necessarily have to live inside the monolith. And we started to decompose this code out of the monolith, creating microservices. One service, a service, and another service. And that's where we are kind of now, trying to break this monolith down into small pieces. And more of these services today are being written in Kotlin. And that actually makes our developers happy again. So to accelerate this process, Atlassian created a platform to help its developers build and deploy and run services. We call this platform Micros, It's not really any magic, it's just an opinionated tech stack and a lot of automation. It allows us to write our code, put it in a Docker container with a little descriptor, and then the platform will deploy the service and provision all the resources that are needed, the compute, database, and everything else. It also adds some monitoring on top of it, and that helps us running the service with the philosophy, you build it, you run it. As I said, we need a little simple descriptor. So this is an example. I just need to provide the name for my service and port that I want to be exposed to the internet. Then a link to a health check, so Micro's platform will know my service is running or not, and any resources that I want to get provisioned, like DynamoDB in this case. And as I said, we use Docker containers for our services, and you can put basically anything in the Kotlin, into the container. However, we had to decide some rules, like we cannot just put anything there because that will be difficult for all the developers. So at Atlassian, the teams are autonomous, but they also agreed on certain tech stacks. And Jira Software has their own group called Java Working Group that defines the tech stack. And right now, we have decided that Kotlin will be the language of choice for all new services. We're going to use Spring Boot as an application framework. We can choose DynamoDB or PostgreSQL if we want to choose data storage. And for any reactive code, we have to use Project Reactor. So why Powered by Kotlin makes the developers happy? This is an example of Java that is pretty long. This is a typical scenario when you want to get a field somewhere deep in hierarchy, and then you want to, for example, calculate the length of that field. So this example is a person is department and the text of that department. In plain Java, you have to check for nullability on every level. And then when you finally get the length and you put it into an object, not the primitive type, you still have a nullable type. It's either the length or a null. So later you will still have to check whether that thing is null or not. The same code in Kotlin is much shorter. This is called a safe call operator, and it basically gives me either the value or it gives me a null. And I don't have to specify my type. Kotlin will figure that out and say that this length is a nullable integer. So I still have this problem that this length can be either a number or a null, and I'll have to check that later. However, in Kotlin, I can say, well, this length is non-null. It's just an integer. It cannot never be null. So what happens if I try to assign this code into this length? Well, I'll get a compile error, and that's exactly what I want. I want to catch all these problems before they happen in the runtime, right? But of course, it's not enough that I like this short syntax. We had to look at Kotlin from a bigger perspective. To adopt Kotlin in a big team like Jira Software, we had to look at some objective criteria. And these 5 criteria that I'm going to present you here, you can use for any technology, I would say. So first, we had to look whether we have enough Kotlin developers available. And luckily, we already had mobile developers who knew Kotlin, who worked with Kotlin, and a lot of backend developers who played with Kotlin on their private projects. We also had to look whether there was any bad experience with Kotlin in the past. We wanted to prevent another Scala situation because we introduced Scala into the code base, and now we have this Scala legacy that nobody really understands and wants to work with. Another criterion was compatibility, because we had a lot of Java libraries, and we had to make sure that Kotlin will play well with those libraries. Again, Kotlin's interoperability with Java is its selling point, so there was no problem there. Next, we looked whether Kotlin is well adopted already in the community, in the developers community. Well, it is actually a de facto standard in Android development. It's officially supported by Spring Boot, and it was made by JetBrains, so the IDE support is very good as well. And last but not least, we had to make sure that Kotlin will make our developers more productive. We found out that we can turn a Java dev into a Kotlin dev within a few weeks. And because people like working with Kotlin, it's a modern language, they also become happier when they work with Kotlin, and that feels a little bit more productive. So I'm not afraid to say that right now Atlasians love Kotlin, and it started to show in our job advertisements because we are looking for people experienced with Kotlin, having interest in Kotlin, and we just simply say that Kotlin is in our tech stacks. Now, let me show you a real application that we have built with Kotlin. Imagine a really real-world scenario. You have a front-end app that is hitting different endpoints or services in a data center. And this happens a lot with microservices. And of course, the more services you extract, the worse it can get. On top of the processing time inside those services, there is latency that is simply the distance between the browser and the data center, between the one computer and the data center. And there's not much you can do about the time here. The only thing you can do is think about your whole architecture to make this faster. So one thing that you can do, and what we did, is you'll put a gateway inside the data center in front of the services. You still have to call the data center, which will take the same time, but then all the other calls happen inside the data center, and these calls are very, very quick. Now, it's obvious that this gateway had to be asynchronous because it calls other services, waits for their responses, and otherwise does mostly nothing, just sits there and waits. We chose Project Reactor because it also gave us a powerful set of operators that are used to modify and combine sources together, and also allow us to compose libraries that add resilience and tracing. It also creates clean code without these callbacks that you can see in completable features in Java and other asynchronous libraries. So if you've never seen Project Reactor, I'll give you just a short intro into a few concepts. First, I would like to introduce a mono. A mono is a stream of one item or 0 items. And in Kotlin, you can turn anything into a mono, into a stream, with this little extension function. Another term is a flux. So let's say I have a list of 3 IDs, and I'm just simply going to turn them into a stream of 0 to n items. We call monos and fluxes publishers. And in Project Reactor, it's very easy to take 2 publishers and create a new publisher as a combination of those 2. For example, I'll take my current board and recent boards. I will concatenate those streams and get the streams that you can see at the bottom. And this will give me a stream that I can call, for example, recently visited boards. This is an artificial example how I could use it. I will take these 2 streams, concatenate them. I will translate every ID into its name. I will take 3 first item, and then I'm going to print them. This subscribe means I'm subscribing to my new publisher. And the print will happen exactly 3 times. And this is the kind of result that you can expect. Now, I was also talking about the composition and operators. One nice thing about reactive streams that it gives me an easy way of adding things like timeouts, you can see here, and error handling inside that stream. So what this code does is, let's say this board service can take sometimes too long. And because this is not a critical functionality, I don't really mind. I'm going to say, if that takes too long, well, it's OK, 2.5 seconds, and then just print a recent board. I'm not going to wait because this placeholder string is fine. And then the result will look something like this. Now, this was an artificial example. In reality, you will do something like this. Your current board will come from one service, and that can be a microservice somewhere else. And your recent boards will also come from another service. Then you concatenate those 2 streams and do all this mapping and timeouts and take 3 items, and you pass this whole calculation to somebody else who will subscribe to it later. And when that somebody subscribes to it, these 2 services are actually triggered at the same time. And when the results come, the results will be combined into the stream that you consume. And this is where you get parallelism for free. Another thing that we picked was GraphQL. GraphQL is a query language, and it sits probably next to REST, or a little bit above REST for APIs. What I like about GraphQL is that it has a strongly typed schema. Strongly typed means it's safer, and it also works as a living documentation that doesn't get out of sync with your code. Like REST APIs, you have to make sure that you have a synchronization between like a Swagger docs and your code. It also helps you to query for exactly what you want, and you don't have to query for things you do not want. And you can query for multiple sources at once. This results in less traffic and less requests. And there are mature web clients like Apollo and Relay for GraphQL that you can use in your JavaScript front-end apps. So this is an example schema, and it's very similar to what we are doing in Jira Software. So this schema it allows me to query for a board by its ID. That's what the type query means. And a board is a simple object that has an ID, name, and a list of issues. An issue is a simple object that has an ID and a key. And let's say I want to query a board by ID 42, and I'm only interested in its name and its issues. I don't care about any IDs. I'm going to post this body into the endpoint that you see above, and this is a real endpoint. If you go to Jira and you create a next-gen board, and you can take a look at the network tab, you will see a lot of requests to this endpoint. So when I send this query, I will get something like this back, a simple JSON object that has the board's name and the list of issues. And the beauty of it is that you don't really know that, but the name and the issues, they come from different places. But you don't really care. The caller doesn't care, right? So we picked Project Reactor and GraphQL Java. Project Reactor is a reactive streams framework, and GraphQL Java is built on completable futures. Now, there is a big danger when you use one framework and combine with another, always. But it's especially true for reactive programming and non-reactive programming. The problem here was that when we go from the reactive world into the completable futures world, we lose something called subscriber context. Subscriber context is something like thread local variables. It lives with your stream. It's available every time when you are processing the stream. But then in the middle, we call GraphQL Java. We cross the boundary from reactive world into non-reactive world, and we lose the context. And we had to get that context back. So we had to hack it and use something in GraphQL Java called data fetching environment. And we save the context there, and we retrieve it later when GraphQL Java gives us the result. I'm not going to show you how that looks like, but I have an example code that I'm going to share with you at the end, and part of this is implemented there. So you can see what the dangers of combining these frameworks are. It's especially true if you combine reactive and synchronous programming. That can be really dangerous. So this was a lot of theory, but let's try to write some code. In the next 15 minutes, I will write this whole gateway that looks almost exactly like the one that we are using. That will show you how simple it actually is. First, we need a REST API that we're going to use in our gateway, right? So I was looking for APIs, and I found this very nice testing API called CatFacts. This is a real API you can try right now. If you send a GET request to this address, it will give you a random facts about cats, like the leopard is the most widespread of all big cats. But I didn't stop there. I also found a dog facts API. And it works exactly the same. You send a request, and it gives you a random fact about dogs. So I could maybe make you vote if you want dog facts or cat facts, but because the whole point is using both, so why not just use both, right? We can make animal facts GraphQL API that will have a query that allows you to query for both dog facts and cat facts. This is not a real URL, but I have the executable code for you later. And I would like to get something like this back, dog facts and cat facts. One thing we can do is go to Spring Initializer, which is a website from Spring Boot that allows you to create these skeleton projects. If you ever used Spring, you probably know this website. And I'm going to use the web flux for my REST API. That's one of the options in the Spring Initializer. And the only thing I have to add for this whole code is this dependency, the GraphQL Java dependency. Now, the entry point to the application in Kotlin is very, very short. This is how it looks like. And this is my GraphQL schema. Again, query starts with a query, and it allows me to query for cat facts and dog facts. And a fact is a simple object. It has the actual fact and the length of the fact, because that's what one of the APIs provides. These two things are fetched by data fetchers. A data fetcher is an interface that GraphQL Java wants me to implement. And again, you can see the first line is a Java interface, but I'm implementing it in Kotlin. I'm going to create my own fact fetcher in Kotlin. Notice this completion stage that comes from completable futures. Another thing about Kotlin is that they have very useful data classes. A data class is like a Java POJO, and when I make the definition like this, it also gives me all the getters, setters, constructors, an equals method, hashcode method, and a toString method. In fact, this one is immutable, so it doesn't have any setters. It just has the constructors and getters. Why is this useful? If you remember the GraphQL schema, usually that's what you write first. You want to write your GraphQL schema first. So you work with a schema-first approach. And then you need to write a lot of these simple objects that represent the schema parts. And Kotlin helps with that a lot. This is the whole cat fact fetcher. This component, this Spring component, is all you need to fetch the whole cat fact, plus the little data class in the bottom, which represents the response from the API. This web client here is the reactive web client that Spring Boot gives me. And when I get the response, I'm going to turn it into a mono, into the stream of 0 to 1 items. It's either there or it's not there. Then I'm going to map it into my internal representation of a fact. And I'm going to turn it into a future because that's what GraphQL Java requires. A dog facts fetcher looks almost exactly the same. You might have not even noticed I changed slides. The only difference here is the URL, and that I don't have the length of the fact, but I can simply calculate it here directly in the mapping. Then I have to do a little bit of configuration. I have to tell GraphQL Java, where is my schema? I think that now when you use any of those new GraphQL Java Spring Boot starters, some of these things are done for you, so you don't have to take care of that. One thing that we have to do is define a wiring. A wiring in GraphQL Java means that whenever there is a dog in the schema, I'm going to use the dog fact fetcher to fetch it. And whenever there is a cat, I'm going to use the other fetcher, the cat fact fetcher. A simple call to the actual library, to the GraphQL Java library. You can see that I'm constructing a GraphQL request with the new schema, and I'm executing this asynchronously. This is the Java code because of the completable features. But at the end, I'm going to turn it back into a mono. And the last part is defining the GraphQL REST endpoint. Again, this is probably not necessary anymore because it's a default path. It's already defined, but I like to show it because of this line. You notice that what GraphQL Java returns is a simple map of string to an object, or you can see here map of string to any in Kotlin. But this call to specification will validate that result against the schema and throw an error if it's not a valid response. And that's it. If I run the application and I send the simple query, I will get something like this back. I will get 2 facts, 1 for dogs and 1 for cats. So this is a very, very basic GraphQL gateway, and all the code was on the slides. There's very, very little extra code, maybe some boilerplate. If you look at the example that I have at the end, this is it. However, this whole gateway is not very good. And why it's not very good? Because it's not resilient at all. And that's a really, really important part of it. And if you're writing a gateway, I'll give you a scenario. So in reality, the docfacts API takes about 250 milliseconds to fetch the fact, and the catfacts API takes about 380 milliseconds, depending on your location. It means that the whole gateway will take about 380 milliseconds, which is the longer of those two calls, thanks to the asynchronous nature, because they don't wait on each other. It's all triggered in parallel. But what happens if one of the API is broken? Depends on how is it broken, but very likely I'll get a timeout. And a default timeout somewhere hard-coded might be like 30 seconds. And that means that this whole thing will take 30 seconds. So if a client asks for docfacts and catfacts, and the catfacts API times out, well, they will get a docfact, a null catfact that they cannot do anything about, an error message, and it all takes 30 seconds. And that's not very nice. So what we can do is we can shorten this timeout. We can say, for example, let's make it only 5 seconds. I like to add these timeouts because I believe that we should always set timeouts to something like a maximum tolerable value. And it's actually very simple to do in the reactive code. It just needs this one little line here. So this is the catfact fetcher I was showing before, and I'm just going to add a timeout here. In reality, this might not be as simple depending on which framework for your calling are you using. But in basic stuff is like this. You just add a timeout here. Now the user will again get a docfact, a null catfact, an error message, and it takes 5 seconds. But can we do even better if we already know that the catfacts API is broken? Like, we already want to just like not call it at all and just tell the user that here's your docfact and you will not get a catfact right now. And turns out that we sort of can with a circuit breaker. A circuit breaker works like an electric circuit. If it's closed, it allows me to pass the signal and call the catfacts API. And that's the happy path. Now, what happens when the catfacts API is broken? I'll start getting errors back. Every time I call the catfacts API, or maybe 50% of times, I'll get an error. So let's say I decide that if I get more than 50% errors, I'm just going to open the circuit. I'm not going to call this API anymore because it's always taking 30 seconds to get the result back. Now, I also have to check whether this API was fixed. So we set a time after which we allow a few requests to pass through. This is called a half open state, and it will allow maybe 5 or like a handful of requests to go and ask the catfacts API, hey, is everything okay? And the catfacts API is still broken, so fine, we just go back to the open state. At some point, of course, the API will be fixed, as normally services get fixed by somebody. So after this time elapses again, we try to call this catfacts API, and it will be successful. We will get a result, and we close the circuit, and everything works business as usual. How does that look like in our code? Again, it's a very, very simple change. You can add a transformation into your stream, and you can use a circuit breaker operator like I'm using here. This comes from a library that I'm going to be showing later as well. There's a little setup that you have to do, and getting these values right, like 50% calls or a number of calls, might be tricky. And that's the whole difficult part of it. But otherwise, it's very simple. What does the user get? A docfact, a null catfact, and some error message that it's either the default or we can define our own. But this whole thing only took 250 milliseconds, and that's how long does the docfacts API take. Is there any downside in using a circuit breaker? Well, maybe we could have missed some of the catfacts. But for the caller, it only looks like that the CatFacts API was broken a little bit longer. So we can write our application in a way to make up for it. Now, again, a lot of theory, a lot of code, but you don't have to remember all of it. But I would really like you to take away from this presentation 3 things. First, if you have an application, if you're writing an application that waits a lot or is I/O heavy, like calling all the other services all the time, consider reactive streams. It really makes nice code. You can use GraphQL for APIs that are consumed from the front end or consumed by third parties. And definitely add some resilience into your applications, into your services, because that's how you prevent propagating errors downstream. Imagine that the front end would have to wait 30 seconds for result when there is a problem. All right, so this is the end of the presentation where I would normally go to the questions, but because this is a Kotlin presentation, and because I didn't say the word coroutines, and somebody always asks about coroutines when I'm speaking about asynchronous processing, I'm just going to answer the question straight away. Why didn't we use coroutines? Well, the whole thing was written in 2018. We started in January 2018, and coroutines at that time were an experimental feature in Kotlin. And we couldn't have that in a production service. But right now, there is support for coroutines in Spring. And in fact, there is a new utility for Project Reactor that allows you to seamlessly go from coroutines into the reactive streams and back. Again, GraphQL Java, why didn't we pick, for example, GraphQL for Kotlin, written in Kotlin, a native library? That was because GraphQL Java is actually an open source library maintained by Atlassians. But there are pure Kotlin alternatives, so feel free to use any other implementation. They will probably work in a very similar way. And a list of resources, as I promised in the middle of my presentation, that can help you write your own reactive and resilient GraphQL gateway in Kotlin. First link is the actual application that is executable. It's a Spring Boot application that you can run on your laptop, and it calls both of the APIs. Then link to GraphQL Java, which is the library that I was using to write this application, and resilience for J. I mentioned this when I was speaking about the circuit breaker. This is a state-of-the-art library for resilience. Highly recommended. Another thing that I didn't talk about, but is very useful, is a tool called Graphical, which is sort of like Swagger for GraphQL. You can bundle that to your application, and it will allow you to debug your GraphQL queries, and also serves as the documentation that users can browse. And the last link here is the coroutines reactor, which is, for those fans of coroutines, is a library that can help you to transition between reactive world and coroutines world, which is not exactly simple without this library. If you want to know more about how Trello is using Kotlin, I have a link to Trello tech blog. If you are interested how Atlassian built other services, there is an Atlassian engineering blog. We also have a new blog at Medium, but specifically this article at our blog is talking about the services. And slightly outdated, but still relevant talk about Micros, which is our platform that is running most of our services. If you were confused by that picture of the girl that says, why not both, I have a link for you as well. And if you would like to work with us writing Kotlin services, we are hiring. So this is the end, the real end of the presentation. I'm going to stop sharing my slides. But if you have any questions, I'm going to be here until the end, which is another 10 minutes. Okay, I'm going to just quickly look at the chat, if I can stop it scrolling. So first question was, how did you manage new features at both monolith and microservices projects? Oh, that's a very good one. So this gateway can actually help you because it is like we can call it a strangle pattern. You have front end, then there is the gateway sitting just before the services, and then you have the legacy code and the microservices. And in your gateway, you control which way you go. So front end doesn't care. Front end only goes to the gateway, and then the gateway will decide whether to go to the legacy service or the microservice. So this gateway can help you with this migration. That's what we are doing right now as well. It would be interesting to have a API liveness probe to switch the circuit breaker back to an open state for the cat API. Yes, you could do that. Exactly. You could just have a scheduled call that once the circuit breaker is down, you can probe the API. Yeah, because this API is idempotent. You don't change anything, so you could do that. Any plans to migrate to Kotlin Flow in the future? Okay. Yeah. Flow is another thing from the coroutines world, I believe. We don't have any plans, but we also don't plan to write any services right now, as long as I know. And I think we will be sticking with our stack for any new service anyway. Yeah, I'm going to share the presentation with the organizers, however they want. So yeah, the question was, is it possible to share the presentation? The answer is yes. If you have any other questions, I'll still be in the chat. A lot of thanks you. I thank you as well for being here, and I hope you will enjoy the rest of this conference. Ah, there's another question. What would you suggest for Java developers starting in Kotlin? What to watch out for? I would suggest starting just by reading the Kotlin docs, the official documentation at kotlinlang.org. They are very, very good, and just go and try it. You can also translate your code from Java to Kotlin in IntelliJ IDEA. But yeah, if you write it, the code is probably looking a bit better. What to watch out for? It's always tricky when you start with new language. There's a lot of Kotlin idioms that can help you, but also confuse you. There's not really anything that you need to watch for, but yeah, writing idiomatic code will help you a lot.